Assalamualaikum and hi, welcome to Chapter 7 Chemical Bonding for the subtopic 7.2 Molecular Shape. The course framework for this subtopic is explain valence shell electron pair repulsion theory, VESPER, draw the basic molecular shape which are linear, trigonal planar, tetrahedral, trigonal bipyramidal, and octahedral. And the third is predict and explain the shapes of molecule and bond angles in a given species. Before we go further into this chapter, there are several things you must know. There are valence electrons, electronegativity, Lewis dot symbol, and chemical bonding. All these terms you have learned during the previous lessons. Okay, I'm sure that you have come across with a various molecular formula. Okay, there are such as beryllium chloride, BeCl2, ozone, O3, methane, CH4, or even ions such as OCN-. But have you ever wondered what are the actual shape of this compound? For normal things, we have shapes like circle, square, triangle, rectangle, and so on. But do molecules have the same shape as well? This is what we're going to learn. So previously in Lewis structure, we know that Lewis structure shows the numbers and types of bond present in molecules, but they do not convey any information about molecular geometry. Okay, what is actually molecular geometry? Molecular geometry is the three-dimensional arrangement of the atoms within the molecules. This means that molecular geometry shows you how the atoms are really bonded to another atom in the space. It can be predicted by using the valence shell electron pair repulsion, also known as VESPER theory. Okay, so VESPER theory plays a very important role in determining the molecular shape. So VESPER stands for valence shell electron pair repulsion. Once again, I repeat, valence shell electron pair repulsion. So according to the VESPER, electron pairs, which are bonding pairs and lone pairs surrounding a central atom, repel one another. We know that electron is a negatively charged particle. So electron pairs repel because we know the same species repel, but the different species charge attract one another. So those electron pairs are oriented to be as far apart as possible to minimize electron pair repulsion. This means that the electron will be the most stable when they are far apart as possible. So this is what we call VESPER theory. So the order of electron pair repulsion is lone pair has a stronger repulsion than lone pair bonding pair. And this lone pair bonding pair repulsion is stronger than bonding pair. So in order, you can see as in the slideshow, the order of decreasing strength of repulsion. There are 5 basic molecular shapes that derive from VESPER theory. These basic shapes is formed when there are only bonding pairs at the central atom without the lone pairs. So the linear shape is formed when there are 2 bonding pairs at the central. The next shape is trigonal planar, tetrahedral shape, trigonal bipyramidal shape, and octahedral shape. Let's look for the first molecular shape, which is linear. So linear is formed when there are 2 bonding pairs at the central atom. For the example, beryllium chloride, BeCl2. So as you can see, the Lewis structure here, there are 2 chlorine atoms bonded to beryllium. So the beryllium has two bonding pairs. These two bonding pairs will form a linear shape with the bond angle of 180 degrees. The general class for linear shape is AX2. A is for the central atoms and X is for the number of bonding pairs. The next molecular geometry is trigonal planar. So the shape is formed when there are three bonding pairs at the central atoms. For example, we have boron trifluoride, BF3. So there are three fluorine atoms bonded to the boron atom. All the three bonding pairs are arranged so that the bond angle will be 120 degrees. So this is the arrangement where the three bonding pairs is far apart as possible. So the general class for trigonal planar is AX3. A is for the central atom and X is for the number of bonding pair. The third shape is tetrahedral. So tetrahedral is when four bonding pairs attach to the central atom. For the example, we have methane CH4, where carbon is the central and hydrogen as the terminal. Determination of atoms to be at the central or terminal, you have learned it in the Lewis structure. Okay, so all the four bonding pairs are arranged to be an angle of 109.5 degrees. Okay, and the shape is called as tetrahedral. The general class for tetrahedral is AX4. The central atom has four terminal atoms. A is for the central atom, X is for the number of bonding pairs. The next one is trigonal bipyramidal geometry. So this trigonal bipyramidal is arise when the central atoms have five bonding pairs. For the example, phosphorus pentachloride, PCl5. The phosphorus, the central atom, and chlorine as the terminal. As you can see from the Lewis structure, there is no lone pair and only the bonding pair. So all five bonding pairs here is located like the picture. There are two bond angles for trigonal bipyramidal, which are 90 degree and also 120 degree. Trigonal bipyramidal is the only molecular geometry with two bond angles. So as you can see, why the name is trigonal bipyramidal, because the structure of the molecule is like we are having two pyramids with the base of trigonal shape. The general class for trigonal bipyramidal is AX5. A central atoms and X 5 bonding pairs. The last molecular geometry is octahedral. So the octahedral is formed when the central atom has 6 bonding pairs. For example, the sulfur hexafluoride, where the sulfur is the central atom and fluorine as the terminal. As you can see from the Lewis structure, the sulfur have 6 bonding pairs. So the 6 bonding pairs are arranged in a manner so that it forms a vertical and also a plane of 4 atoms. And all the bonding pairs has a bond angle of 90 degrees. Okay, so actually the structure or the geometry is like two pyramids on top and at the bottom. And the general class of octahedral is AX Here is the summary of what we have learned today. And that's all for 7.2 molecular shape. Hope you understand. Bye.